Hello, what's up guys? Today I'm here with another video. So today I will be talking about the thumb rule for determining the size for the column and beam. This is very important during the time of analysis and designing using the software like STAADPRO or ETABS. So before you give the sizes and all in a software, you should be knowing the basic thumb rule for the determination of column and beam. So as you can see, here is a given plan. So architect will provide you the drawing, so that you proceed for the analysis. So before you put the value or the size of the structure in a STAADPRO or ETABS, so you should be knowing the basic thumb rule to determine the size. So as you can see here, the plan first span you can see 4100, here 3750, and here also 4100, and so on. So for determining the size of the beam, firstly if you see, first if you go for depth, there are three different things to determine the depth of beam. So it is categorized as firstly light load. So if your building has a light, like if there is not much load coming from the superstructure, so you can take the L by 15 to L by 20. So L here basically represents the span of your this one. As you can see here, 4100, 3000. So you have highest span is among them is 4100. So here in my case I can take the medium load. So here L represents the span. So in given plan we have seen that highest span is 4100. So I'm taking the reference on for this one 4100. So let's divide span by 12. I'm taking the medium load. So highest span is given in plan is 4100 mm. So depth can be determined span by 12. So it's coming 4100 by 12 comes 3.41. So we can approximately take 400 mm depth for the safer side. So therefore D is 400 mm. So for the beam width, there is again one criteria, depth by width, which we should lies between 1.5 to 1.8. That ratio should be lies between this one, and another width by depth should be greater to 0.3 as per IS 13 and 19320 code. So let's take W as 250 mm. So if you compare the ratio, it's like it falls between this one, and also it's greater than 0.3. So these two categories fulfilled. So width as 250 for the beam. So I can take size as 250 mm width times D as depth as 400 mm. So for column size, now during the time of analysis and designing, you always consider, you need to consider this concept, weak beam strong column concept. In most of the books and authors, they have always suggested this concept, because during the time of seismic, your beam may chances of failing, but at the time your column should not be failing. If you don't follow this concept, and if like seismic comes and if column first fails, then it's no use of your structure. So you always consider this concept, weak beam strong column concept. So in above we have seen the beam size as 250 width times 400 depth for this given plan, for this structure. So you can also take you can, in similar way, you can also consider that way. So in my case I have beam size as 250 width by 400. So its area, cross section area, comes around 1 lakh. So 1 lakh mm square, right? So column to be decided greater than beam cross section area. So after the hidden trial, we can consider as 300 by 300 we cannot take because it comes at around 90,000 mm square, so it's less than this one size of cross sectional of beam size. So let's take consider as 350 mm by 350 mm for the column. So if you check the net area of our column, then it comes around 18% higher than the beam size. So using this concept, if you proceed for the designing and all, then at the first hit and trial only your structure will get passed. So this is basic thumb rule that you need to follow during the time of analysis. So next, if you come to the slab depth or slab deciding the slab thickness in two way, as per IS 456 clause 24.1, for continuous slab your coefficient will comes around 32, which means for HYST bar multiplied by 0.8, so it comes around 32 coefficient. So in my case in above given plan, I after deciding the highest span out here, so here I can we can see here highest span for this one is 4.1 by this one 3750. So I can consider slab opening as 3.65 meter times 4.1 meter. So we always decide from the smallest span, so 3.65 into times 1000, which will be in mm, so divided by 100, it comes around 114 mm. So this one is required depth, right? So let's take D as 150 mm for the safer side. So this is how you decide the things, I mean thickness for the slab. So these all are the thumb rule to decide the sizes of the beam and column, and also the thickness of the given slab. So this is how you decide, and this is the thumb rule for the analysis before you proceed for analysis. So in my case, so here you can see for span you have seen 250 width and 400 depth. Here also we can, so accordingly we can, because this is the highest span, and based on that you are designing. So this is how you decide for the I mean this is thumb rule how you decide the sizes. Thank you, hope you guys have got some tips from here. So see you, bye bye guys.